Here are the answers for the section 7-8 word problems assignment. Starting with number 1. This talks about a trapezoid. It refers to the length of the bases, and it mentions the word area. So the first thing I've done is written down the formula for area of a trapezoid from geometry class. Area equals 1/2 times the height times the sum of both bases. As a reminder, a trapezoid has this general shape. The height is the distance from the top to the bottom, and the top is called base 1 and the bottom is called base 2, or vice versa. It really doesn't matter which one you label B1 and B2. Now in the question we're told that one of the bases is 5 more than the other, so I've labeled B2 equals B1 plus 5. We're also told that the altitude, which is another word for height, is 4/5 of the longer base. So I'm able to write h equals 4/5 of, or 4/5 times, the longer of the bases. Finally, to avoid using subscripts, these little numbers in the bottom corners, as we do our algebra, let's just use the letter B instead of B1. All right, so we're all ready to do this problem. We're going to use this formula for area of a trapezoid and fill in 100 square centimeters for the area. On this side, for the letter H, we're able to fill in 4/5 times B plus 5. And for B1, remember we just decided to use the letter B. And for B2, we can fill in B plus 5. So I'm taking the equation for area of a trapezoid and making substitutions. For area, 100. For h, I'm putting in this expression that we figured out. And for B2, I'm filling in this expression. Now let's simplify this up on this side. 1/2 of 4/5 is 2/5. And in these parentheses, B plus B is 2B. Now let's multiply both sides of the equation by 5/2, because multiplying 2/5 by its reciprocal 5/2 will cancel away that fraction. 100 times 5/2 is 250. This is a binomial times a binomial. We can do FOIL. B times 2b is 2b squared. B times 5 is 5b. And the inner product is 10b. Those combine to 15b. And then 5 times 5 is 25. Now we see we have a quadratic equation. Let's get it to equal 0 by subtracting the 250 from both sides. Our quadratic equation is in standard form. So the fastest way to solve it is probably the quadratic formula. The value of A is 2, B is 15, and C is the negative 225. With the quadratic formula, we know that X equals, but in this problem it's B, negative 15, plus or minus, and then 15 squared, which is 225, minus 4 times the value of A, which is 2, times the value of C, which is negative 225. And that's all divided by 2 times A, so 2 times 2, which is 4. Now let's do work inside the radical symbol. I'm going to take a calculator and type in everything that's inside of that square root. That makes 2,025. And that's still all divided by 4. Now let's figure out what the square root of 2,025 is. That's 45. This is going to generate two answers for the length of the base. The first answer is figured out by using this plus sign. Negative 15 plus 45 makes 30, and 30 divided by 4 makes 7.5. The other answer is figured out by using this minus sign. Negative 15 minus 45 is negative 60, and negative 60 divided by 4 is negative 15. Now let's think about what the letter B was representing. It was representing the length of one of the bases. Does it make sense that a base of a trapezoid can be negative 15 units long? No, lengths cannot be negative numbers. So we have to cross that one out and use 7.5 for the length of that base. Now how long was the other base? If base number 1 is 7.5 centimeters, then base number 2 is 7.5 plus 5, which is 12.5 centimeters. Here are the lengths of the two bases of our trapezoid. Number 3, for the most pleasing effect, the ratio of the width of a rectangle to its length should equal the ratio of the length to the sum of its length and width. We call this the divine proportion, or golden ratio. It is used a lot in design and architecture. I've written down that first sentence using symbols. The ratio of the width to the length is equal to the length compared to the width plus the length. The problem also discusses the perimeter, so I've written down the formula for perimeter. Now let's take this proportion and solve it using the cross multiplication technique. L times L is equal to W times W plus L. Next, I'm going to go over to the equation that involved perimeter and make the substitution of 50 inches for capital P. Then solve this equation for one of its variables. I'm choosing to solve for the L, so let's subtract 2W from both sides. We have 50 minus 2W is equal to 2L. Then divide both sides by 2. We get 25 minus W is equal to L. This expression, 25 minus W, can be substituted in place of the letter L. So if we go over to this equation that we had started to write, every time we see an L, we can fill in 25 minus W. Then do some simplifying on this. This right here we can use FOIL. 25 times 25 is 625. Then minus 50W plus W squared. Over here on this side, inside the parentheses, notice how W minus W cancels away. So we're really left with W times 25, which is 25W. This is a quadratic equation because it goes to the second power. Let's get it to equal 0. We need to subtract the 25W away so that there's a 0 on the right side. Now we have standard form. We can solve this with any of the methods that we know about. Maybe it factors, or maybe we could do completing the square. I'm going to choose the quadratic formula, however. A is 1, B is negative 75, and C is 625. So our answer for W can be found by taking the negative of B, so 75, plus or minus, now square root, and then right in here we're going to go B squared, so negative 75 squared. That makes 5,625. And then 4 times A, which is 1, times C, which is 625. And that's all divided by 2 times a, so just 2. Now let's do some work inside that radical symbol. I'm going to take a calculator and type this whole thing inside there. That turns out to be 3,125. Now let's take the square root of 3,125 to get a decimal. That's approximately 55.9. This is going to generate 2 answers. To get the first answer, type it in using the plus sign. So 75 plus 55.9 equals, and then divide by 2. That's 65.5. To get the other answer, type it in again using the subtraction symbol. 75 minus 55.9 equals, and then divide by 2. That's 9.6. Remember what the letter W was representing, the width of a rectangle. So these numbers are in inches. The question asked us to give the dimensions. That's the length and the width. So if we already figured out what the width could be, we still need to get the length. We have an equation up above that finds us the length. It is 25 take away the width. Can the width be 65.5? Well, 25 minus 65.5 makes a negative number. The length of something cannot be a negative number. So we found out that that number is not possible. Let's cross that out. Now what if the width was 9.6? 25 minus 9.6 will turn out to be a length. And that's 15.4 inches. So now we know the dimensions of this rectangle. It's 9.6 inches wide and 15.4 inches long. Number 5, the volumes of 2 spheres differ by this many cubic meters, and the length of their radii differ by 6 meters. Find the length of the radius of the smaller sphere. So I took the first sentence and I showed it out like this. The volume of the first minus the volume of the second is equal to 336 pi. And I took the next part and I wrote it like this. The radius of the first is equal to the radius of the second plus 6 more. Then I used this formula from geometry class for volume of a sphere, 4/3 pi r cubed. And I rewrote this equation using that formula. Next, because both of these contain the 4/3 pi, I used factoring. Now let's divide both sides by 4/3 pi. To cancel this away, we get the first radius cubed minus the second radius cubed is equal to whatever 336 pi divided by 4/3 pi is. That makes 252. Next step, do you remember how we said that the first radius was 6 more than the smaller radius? Let's substitute this r2 plus 6 in place of r1. And then so that we're not using subscripts in our algebra, let's just rewrite this using a regular r. Next up, let's do some simplifying on this. This part right here involves cubing this binomial. With repeated use of FOIL in the distributive property, that makes r cubed plus 18r squared plus 108r plus 216. And then we have the minus r cubed and the equals 252. Next up, the r cubed and the minus r cubed will cancel away. So we have 18r squared plus 108r plus 216 is equal to the 252. Now let's get a 0 on the right side by subtracting the 252. All of these coefficients will divide evenly by 18, so that'll make the problem look a lot simpler. We have a very straightforward quadratic equation. Let's use the quadratic formula, where a is 1, b is 6, and c is -2. We want to take the negative of b, so -6, then plus or minus the square root, and then b squared, that's 36, minus 4 times the value of a times the value of c. That's all divided by 2 times a, which is 2 times 1, or just 2. Now let's do some work inside the radical. -4 times 1 times -2 makes 8, and 36 plus 8 is 44. Next up, think of 44 as 4 times 11, because you can take the square root of the 4. We get -6 plus or minus 2 square root of 11 all over 2. This reduces to -3 plus or minus the square root of 11. Now, about how large is the square root of 11? If you find that as a decimal, you would get that the square root of 11 is about 3.3. -3 plus 3.3 makes 0.3. But -3 minus 3.3 makes a negative number, which is not possible for a radius of a sphere. So the only possible answer is 0.3 meters. We got this answer by going -3 plus the square root of 11. And if you look in the back of the book answer key, I think that's how they left their answer, as -3 plus the square root of 11. Now for the review assignment. On page 276, the oral exercises, number 2, we're asked to put it in standard form. So we need to add the x and subtract the 4. We get x squared plus x minus 4 equals 0. For problem number 10, we have standard form, and we're asked for a, b, and c. So a is the 4, b is the -3, and c is the -7. For the written assignment, we're asked to solve the equation, but number 7 says we have to do completing the square. So first step, get it in standard form. So 6x squared plus 11x minus 10 is equal to 0. Next up, let's factor out the 6. So we get 6 times x squared plus 11/6x minus 10/6 is equal to 0. Now let's redo this trinomial so that it's a perfect square trinomial. Find out what half of the 11 over 6 is. That's 11 over 12. And then square the 11 over 12. That makes 121 over 144. That's what we want this constant to be. But right now, that's not what it is. It's -10 over 6. So what do we have to add to the -10 over 6 to make the 121 over 144? Let's do a little bit of scrap work and figure that out. -10 over 6 plus something, we want to be 121 over 144. So let's add 10 over 6 to both sides to figure out what that unknown value is. It's 361 over 144. Let's rewrite our problem. If we add this number in on the left side and this number is in the parentheses, which is multiplied by a 6, then by how much have we really changed the left side? We've changed it by whatever 6 times 361 over 144 is. Let's figure that out. That's 361 over 24. So to compensate by changing the left side by that value, we need to add that same amount on the right side. Now let's rewrite that trinomial in those parentheses. The trinomial is now a perfect square trinomial, which factors as x plus 11 over 12 squared. Now divide both sides by the 6. Then take the square root. On one side we get x plus 11 over 12. And on the other side we get the positive and negative square root of 361 over 144. Now does this turn out to be anything nice? Let's use the calculator and try to find the square root of 361. It's 19, and the square root of 144 is 12. So this is equal to x plus 11 over 12 plus or minus 19 over 12. Now subtract the 11 over 12 for both sides to get x alone. Oops, right in there I lost my equal sign. This is really going to give us two answers. Negative 11 plus 19 is 8 over 12. And for the other answer, negative 11 minus 19 is negative 30 over 12. Both of these are reducible fractions. This is 2/3, and this one over here is negative 5 over 2. The reason this problem took so long is because the book said we had to use completing the square. That probably was not the most effective method when the value of a was a 6. I bet the quadratic formula would have been a lot easier in the long run. For number 15, we're asked to use the quadratic formula. So the value of a is the 3, b is the 8, and c is the 2. To solve for n, we're going to use negative b, so negative 8, plus or minus the square root. Now b squared, that's 64, minus 4 times the a times the c, all divided by 2 times the a, so 2 times 3, which is 6. Next step, figure out what's inside that radical. That makes 40. Next step, let's simplify the square root of 40. Think of the square root of 40 as a 4 times a 10, because you can find the square root of 4. It's 2. This is reducible. We get negative 4 plus or minus the square root of 10 all over 3. Here are both answers if we leave it in this combined format. Number 21, we're asked to solve this equation using any method we want. It's in standard form almost, except standard form doesn't have decimals. So if we multiply everything by 10, we can remove those decimals, which might make the work easier later on. Now we see that a is 35, the b is negative 1, and the c is negative 6. So to solve for y, we want to go negative of b. So negative of the negative 1 is a regular 1. Now b squared, negative 1 squared is 1. A is 35, and the c is negative 6. That's all divided by twice a. 2 times 35 is 70. Now inside the radical, what number does that all turn out to be? It's 841. Does the square root of 841 produce an integer? Let's use a calculator to find out. Yup, it's just 29. This is going to make two answers. 1 plus 29 is 30 over 70. And the other answer is 1 minus 29, which is negative 28 over 70. Both of these are reducible fractions. This is 3/7, and over on this one, they both divide by 14. So this is negative 2 over 5. Number 27, we're asked to solve this equation using any method we want to. These have fractions, so the technique is to multiply by the LCD. The LCD is going to have t plus 3 and t minus 1. The t plus 3's cross out, and we're left with 1 times t minus 1. That's just t minus 1. In this area, the t plus 1's cross out. Oops, I made a mistake. I see that my LCD is t plus 3 times t plus 1. Let me make that t plus 1, t plus 1, t plus 1, and this right here, t plus 1. Sorry, I didn't notice that earlier. Okay, the t plus 1 crosses the t plus 1. So 1 times t plus 3 is t plus 3. And then on this side, let's do FOIL on this. T times t is t squared. T times 1 is 1t. The inner is 3t. Those combine to 4t. And 3 times 1 is 3. T plus t is 2t. 1 plus 3 is 4. This is a quadratic equation because the highest degree is 2. Let's make standard form. Now solve the equation using any of the methods we know about. I'm going to choose completing the square. Half of 2 is a 1, and 1 squared is a 1. So I would like the constant term to be a 1, but it's not. It's a minus 1. If I add a 2 to it, however, it will become a 1. And to compensate, add 2 on this side. So our trinomial is now t squared plus 2t plus 1, and that's equal to 2. Now factor that perfect square trinomial. Now take the square root of both sides. And finally subtract 1 from both sides. And here are our two answers for t. On page 272, we're asked to simplify this. This has the format of being the distributive property, where the thing out at the beginning is going to get multiplied to both of those items in those parentheses. So negative 2 square root of 21 times 7 is equal to negative 2 times the square root of whatever 21 times 7 is. That's 147. And then negative 2 times the square root of 21 times over to here becomes negative 4 times the square root of whatever 21 times 3 is, which is 63. Now let's see if we can make some like terms. Can we factor the 147 so that one of the things is a perfect square? 147 is the same thing as 49 times 3. Over on this one, can we factor 63? 63 is 9 times 7. The square root of 49 makes a 7, so negative 2 times 7 is negative 14. The 3 is going to have to stay in the radical. The square root of 9 makes a 3, and negative 4 times 3 is negative 12. But the square root of 7 is going to have to stay in a radical. Even with factoring, we were not able to get like terms, so we can't combine any farther. Number 4 has the format of being FOIL, and it's the special case where this is a plus, this is a minus, and these things are identical. So you really only have to do the letter F and the letter L from FOIL. The outer and inner products will cancel away. The square root of 12 times the square root of 12 is a regular 12. The square root of 20 times the square root of 20 is a regular 20. And 12 minus 20 is negative 8. In number 6, we have to square this binomial. So you can write it down twice and use FOIL, or you can use the shortcut method. That's what I'm going to do. The square root of 5 squared makes 5. And then minus twice the product of those two terms. So twice the square root of 35. And then we go plus, and we square the last term, which makes a 7. Now let's combine like terms. 5 plus 7 makes 12. The square root of 35 does not make an integer, and even if you tried to factor, all you'd get is 5 times 7, and neither of those are perfect squares, so this is the best we can do. Number 16, we have a radical in the denominator. This is where you rationalize the denominator by multiplying top and bottom by its conjugate. The conjugate of a binomial is the same terms, but with the opposite sign in the middle. So in the top, 3 times 1 is 3, and 3 times the square root of 3 looks like this. Down in the bottom, let's do FOIL. 1 times 1 makes 1, and then minus the square root of 3 times the square root of 3 makes 3. So now we have 3 plus 3 square root of 3 all over negative 2.